establishing shot of Renaissance Italy, contrasting vibrant culture with rigid Aristotelian cosmology. The universe is visually reinforced by ancient celestial diagrams showing a stationary Earth at the center of all things. Galileo Galilei is born in Pisa, 1564, into a world of breathtaking artistic achievement, yet natural philosophy remains shackled to 2,000-year-old doctrines. Focus on his father, Vincenzo Galilei, a renowned musician and theorist who refuses to accept ancient Greek theories of harmony unquestioningly. Show Vincenzo meticulously adjusting weights on a string, demonstrating his foundational lesson. Empirical evidence holds more truth than the word of any ancient authority. Young Galileo, sent to the University of Pisa for a profitable medical degree, pivots secretly to the irresistible logic and certainty of mathematics and philosophy. Due to financial strain, Galileo is forced to leave the university in 1585 without a degree, marking his first formal act of intellectual independence. In Florence, 1586, he produces his first scientific work, La Balancita, a clever treatise describing an improved hydrostatic balance based on Archimedes' principles. This practical invention brings Galileo early fame, demonstrating a mind that moves seamlessly from abstract theory to tangible, real-world application. His growing reputation secures him a teaching post at the University of Pisa in 1589, allowing him to begin his formal academic challenge to the status quo. During this period, he drafts unpublished essays, De Motu, which mount his first systematic assault on Aristotle's established laws of motion. The death of his father in 1591 places immediate financial and familial burdens squarely on Galileo's shoulders, forcing him to seek a more lucrative position. Seeking better pay and freedom, Galileo secures the prestigious chair of mathematics at the University of Padua in 1592, within the liberal Republic of Venice. Padua years, 1592 to 1510, are the happiest of his life, marked by domestic partnership with Marina Gamba and intellectual ferment. His official duties include teaching standard geocentric astronomy and Euclidean geometry, essential for students practicing medical astrology. Behind the lecture hall, Galileo dedicates himself to secretive research on mechanics and motion, work that will eventually form his greatest contribution. The catalyst arrives in the summer of 1609. News of the Dutch spyglass, an optical instrument making distant objects appear near. Galileo immediately grasps the principles. An animation shows the rapid transition from the crude Dutch design to his own vastly superior instrument. He teaches himself the painstaking art of grinding and polishing lenses, allowing him to achieve unprecedented magnifications, up to 30 times. His first move is commercial, demonstrating the improved telescope to grateful Venetian merchants who see its instant military and maritime value. The reward is a lifetime salary increase from the Republic, cementing his financial security and earning him the necessary resources for further research. That autumn, Galileo performs the revolutionary act, turning his powerful spyglass away from earthly ships and towards the night sky. His first target is the moon, where doctrine demands a perfect, ethereal sphere. Galileo sees a rugged, terrestrial world covered in shadows. Using his skills as an artist, he meticulously draws the lunar surface, revealing mountains and valleys comparable to those on Earth. Applying principles of light and perspective, he calculates the heights of the lunar mountains, proving the heavens and Earth share the same material substance. Next, he turns to the faint ribbon of the Milky Way, resolving the diffuse band into a breathtaking sight. Countless individual stars grouped together. Through his telescope, constellations reveal dozens of previously invisible stars, confirming the universe is vastly larger and more populous than previously imagined. The turning point of Jupiter. He notices small points of light near the planet, initially mistaking them for fixed background stars. Night after night, charting their positions, he realizes the lights move, changing their arrangement relative to Jupiter, but always remaining with it. The inescapable, dangerous conclusion is reached. These are 4 moons in orbit around Jupiter, not the Earth. This single observation delivers a fatal blow to the geocentric worldview, proving the Earth is not the unique center of all celestial motion. Working with urgency, he compiles his explosive findings into Sidereus Nuncius, published in March 1610. The book is an intellectual bombshell, circulating rapidly throughout Europe and immediately transforming Galileo into an international celebrity. A calculated political maneuver, Galileo shrewdly names the new moons the Medicean stars, honoring Cosimo II, the powerful Grand Duke of Tuscany. This strategic flattery offers the Medici a form of immortality, linking their name directly to the heavens and securing critical aristocratic patronage. The gambit works. In June 1610, Galileo leaves Padua for Florence to become chief mathematician and philosopher to the Grand Duke. Now installed at court, Galileo has the freedom and resources to continue his systematic scientific demolition of the old cosmology. He observes that the planet Venus exhibits a full set of phases, ranging from crescent to full, just like the Moon. A clear animation shows this observation is a geometric impossibility in the Ptolemaic system, decisively falsifying the ancient Earth-centered model. By projecting the Sun's image, he observes dark blemishes, sunspots, tracking their movement to prove the Sun itself rotates on an axis. This evidence utterly demolishes the Aristotelian distinction between a perfect, unchanging, ethereal heaven and a corrupt, mutable Earth. In the competitive scientific arena, Galileo employs cryptic, encrypted anagrams to secure priority for his discoveries without revealing the details. Scene depicting the scramble of letters for Saturn's triple-bodied appearance, his rings, demonstrating the high-stakes nature of Renaissance science. He sends a second anagram concerning the phases of Venus, a poetic code that ensures his claim is time-stamped and acknowledged by rivals. Despite the mounting evidence, Galileo faces fierce resistance from entrenched university philosophers whose careers rely on Aristotelian physics. Some opponents refuse entirely to look through the telescope, dismissing the celestial phenomena as mere optical illusions created by the lenses. More ominously, conservative clergy begin to view the moving Earth as a direct contradiction of explicit biblical passages, setting the theological stage. In 1614, the conflict enters the dangerous realm of heresy when a Dominican friar denounces Galileo and his followers from the Florence pulpit. Rome is forced to intervene. In 1616, the Holy Office of the Inquisition convenes a panel to officially rule on the Copernican doctrine. The verdict is swift and definitive. The proposition of a sun-centered universe is declared foolish and absurd in philosophy and formally heretical. Cardinal Robert Bellarmine, a powerful and respected theologian, is dispatched to deliver a formal warning to the astronomer. Galileo is ordered to abandon the Copernican opinion and forbidden to hold, teach, or defend it in any way, orally or in writing. Copernicus's foundational book is placed on the Church's Index of Forbidden Books, where it will remain for the next 2 centuries. Galileo, seeing the immense power arrayed against him, acquiesces to the decree, falling silent on cosmology for 7 years. Archival mystery states Bellarmine only warned Galileo not to hold or defend the theory, a relatively mild instruction. Forensic investigation reveals a second, unsigned document surfaces later, claiming a much harsher injunction, forbidding discussion in any way whatsoever. This dubious, potentially fabricated piece of paper will become the key legal pretext used by the prosecution to condemn him in his subsequent trial. A dramatic shift in 1623. Galileo's longtime friend and intellectual ally, Cardinal Maffeo Barberini, is elected Pope Urban VIII. Galileo is jubilant, believing he now has a powerful protector in the highest seat of the Church, traveling to Rome for 6 audiences with the new pope. Urban VIII grants Galileo permission to write a book discussing the rival cosmologies, dialogue concerning the 2 chief world systems. The permission comes with a critical condition. The Copernican system must be treated strictly as a mathematical hypothesis, not as physical fact. The second condition demands Galileo conclude the book by prominently featuring the Pope's own argument about God's omnipotence and unknowable ways. Galileo spends 6 years crafting his masterpiece, published in 1632, written in lively, accessible Italian to reach a broad, educated public. Salviati, Copernican genius. Sagredo, the open-minded layman, and Simplicio, the dogmatic Aristotelian fool. The dialogue is a masterful work of scientific rhetoric designed to persuade and utterly demolish the geocentric worldview. Salviati's arguments are sharp and evidence-based. Simplicio retreats into circular logic and appeals to outdated authority. The book becomes an immediate success, powerfully swaying educated opinion toward the heliocentric view across Europe. The fatal error includes the Pope's mandatory conclusion, but places the words into the mouth of the dull and dogmatic Simplicio. Pope Urban VIII, already politically embattled and acutely sensitive, interprets this as a devastating public mockery and intellectual betrayal. The friendship shatters. The powerful patron transforms into the chief adversary, driven by personal fury more than abstract theological concerns. The Pope establishes a special commission. Sale of the dialogue is halted, and in September 1632, Galileo is summoned to Rome. The Inquisition trial begins, preemptively structured by the Pope's wrath toward a predetermined guilty verdict. The prosecution's key evidence is the highly questionable, unsigned minute from 1616 claiming total prohibition of any discussion of Copernicus. Faced with this manufactured legal snare and the implicit threat of torture, the 69-year-old ailing Galileo recognizes his position is hopeless. June 22, 1633. Clad in the white shirt of a penitent, Galileo kneels before the solemn cardinals of the Inquisition. Found vehemently suspect of heresy. To save his life, he is forced to formally abjure, curse, and detest his scientific truths. His revolutionary book is immediately and permanently banned by the Holy Office, marking the climax of the conflict between faith and free inquiry. The narrator addresses the legendary moment, the defiant, whispered phrase, "Eppur si muove," and yet it moves. The quote is a compelling myth, appearing over a century later, capturing the spirit of enduring fact. Galileo's sentence is quickly commuted from imprisonment to permanent house arrest at his villa Il Gioiello in the hills of Arcetri. The location is chosen deliberately, close to the convent where his eldest and most beloved daughter, Sister Maria Celeste, lives. Sister Maria Celeste's death in 1634 is a devastating blow, compounding the aging scientist's isolation under house confinement. A profound irony, which had opened the universe, begins to fail, culminating in total blindness by 1638. Though confined and sightless, his mind remains unchained. Forbidden to discuss the heavens, he returns to his early passion, the science of motion. In the solitude of Arcetri, he compiles his foundational work on physics into his true scientific masterpiece, Two New Sciences. The Church, by halting his celestial research, inadvertently catalyzed an even more fundamental revolution, the birth of modern mechanics. Two New Sciences lays the mathematical foundation for physics, precisely describing the parabolic trajectory of projectiles. He formulates the radical law of inertia. An object in motion will continue moving at a constant velocity unless acted upon by a force. The law of falling bodies is established, mathematically demonstrating that the distance an object falls is proportional to the square of the time, d/t². With this single, final work, smuggled out of Italy, Galileo conclusively sweeps away 2 millennia of flawed Aristotelian physics. In a final act of intellectual rebellion, the banned manuscript is secretly smuggled out to the Protestant publishing houses in Leiden, Holland. Two New Sciences is successfully published in 1638, ensuring that Galileo's foundational legacy is preserved for all posterity. Galileo dies on January 8, 1642, still under house arrest. The Church denies him a public funeral or honorable burial in the main basilica. Contrast the simple, inconspicuous room where he was interred with the grandeur afforded to other Florentine intellectual giants, symbolizing his silencing. A cosmic symmetry. Isaac Newton is born in England in the very year Galileo dies, ready to take up his mantle. Newton builds directly upon Galileo's principles of inertia and motion, creating the universal system of mechanics and gravitation, standing on a giant's shoulders. The long rehabilitation begins. The Church slowly retreats from its untenable position, lifting the general ban on heliocentric books in 1758. Finally, in 1992, Pope John Paul II formally acknowledges that the Church had erred in its condemnation of Galileo 3 centuries earlier. Galileo exists today as a complex historical man, a devout, ambitious, and sometimes arrogant courtier, and as a powerful cultural symbol. The symbolic Galileo is the archetypal martyr of reason, the heroic figure of free inquiry, standing alone against entrenched dogmatic authority. His enduring legacy is the establishment of the empirical, mathematical, scientific method itself, a timeless reminder that evidence has a power of its own. Galileo's story has become the foundational narrative for the struggle between free inquiry and authority, proving that even when silenced, the truth moves.